Hey everybody, this is Paul. In this tutorial I'm going to be doing an example of integration by parts. So integration by parts is just another way that we can use to evaluate an integral. And this method is typically taught around the beginning of a second semester calculus course. So basically this is the general form of integration by parts. And if you don't know what this means, don't worry about it. I'll kind of be translating what this means through an example here. So for our example, what we're going to do is we're going to look at the integral of x times e to the x with respect to x. And we want to basically use integration by parts to do this. So what we have to do is we have to label part of this u, and the other part of it we need to label dv. So usually what we want to do is we want to pick the part that will kind of turn into a constant if we take the derivative enough times for our u. So if we take the derivative of x with respect to x, it will turn into the constant 1. So we'll just go ahead and pick that for our u. So we'll just put that over here. U, we decide, is going to be x. And since we chose x to be our u, that means the rest of this stuff has to be the dv. So dv is equal to e to the x dx. And so now that we've got our u and our dv figured out, we also need to figure out what du is, and we also need to figure out what v is. So we can figure out what du is by taking the derivative of u with respect to x. So derivative of u with respect to x is simply just 1, since the derivative of x with respect to x is 1. And then if we just were to multiply the left and right hand side of this by dx, this would simply become du is equal to dx. So we've defined what du is now. So now let's go figure out what v is going to be. So if we were to just integrate the left and right hand side of this right here, we would have the integral of dv is equal to e to the x dx, the integral of e to the x dx. And then if we integrate this side, we simply have v. If we integrate this one, we have e to the x plus some constant, but we're not going to worry about the constant right now. So this is our v. v is equal to e to the x now. So now we have all the parts we need. So basically this is going to equal u times v. U is equal to x. V is equal to e to the x, so this is our u times v right here. And then we just subtract the integral of v times du. v was e to the x, and du was dx. So this simply becomes x times e to the x minus the integral of e to the x with respect to x, which is simply e to the x. And then we can go ahead and add our constant term here. So this is our answer now, and we can actually simplify this a little bit. We can factor out an e to the x out of these first two terms, so this becomes e to the x times x minus 1. And then that's plus some constant. So we went ahead and just solved the integral of x e to the x with respect to x, and it turns out that it's equal to e to the x multiplied by the quantity of x minus 1 plus some constant. So this is the solution, and we got that by using integration by parts. So I hope this example helped you guys understand how to use integration by parts. I appreciate you guys watching. I hope you have an excellent day, and if you haven't already, don't forget to subscribe.